All right, welcome again. So in this video, we are continuing to look at gravimetry past paper questions, specifically just the aspect dealing with calculation. I will do another video where I look at the theory, like the uses of gravimetry and so forth, the uses of why we use each part, so like the Buckner funnel and suction flask and so forth. So parts of the question asks things like those, but I'm just focusing on the calculations in these videos, right? So here we go again. So this is again precipitation gravimetry, where you have to filter, wash your precipitate, dry, and weigh. So this question, it says a sample of potassium chloride. It gives us the formula as well. So we have a sample weighing a mass of 0.45 gram. Potassium chloride is soluble in water. If you remember the question before with calcium carbonate, we had to dissolve it in acid because it is insoluble. But KCl is soluble in water. So we could just dissolve it in water. So you dissolve the 0.45 gram sample in water, and we treat it with excess silver nitrate, and the precipitate of silver chloride was obtained. And as usual, we will always get a mass for the precipitate. So the first question they ask us is to calculate the moles of silver chloride, which is the mole of precipitate. So step one in our calculation is to get the mole of precipitate. So we know the mole is equal to the mass. All right, so we're calculating mole of precipitate, which is AgCl. So the mass of it was 0.8402 grams. Now silver is 108 and chlorine is 35. Chlorine is 35.5. That will give us 143.5. For the answer, we will get 0.0059. So that was part one. Part two, it says, deduce the number of moles of calcium chloride present in the sample. Even though it's 1 mark, you would have to know that. So it says the potassium chloride, so step two, or part two of the calculation, it will always be involved using mole ratio. So KCl reacts with silver chloride, not silver chloride, silver nitrate, and you will get silver chloride with precipitate on it and potassium nitrate. The equation is already balanced. So that means, so remember, when I want mole ratio, it's between the precipitate, since we have the moles of the precipitate and what you're interested in, which is calcium chloride. So it's a 1-to-1 mole ratio between silver chloride and potassium chloride. So the mole of KCl is the same as silver chloride. So the mole of KCl is 0.0059. And that's it. And then the final part now, it says calculate the percentage of calcium in this sample. So remember, before you can calculate the percentage, you have to calculate the mass. So we know that mass is equal to mole times molar mass. So the mole 0.059. And the molar mass, potassium is 39. And chlorine is 35.5. The molar mass for it is 74.5. .4396 grams with 0.4396 gram. And then part 4 now, well, it's still part 3. So the first thing we needed to do was to find the mass of KCl. So this is the mass of KCl. So now the percentage it's the mass of the compound. So that's 0. And the final answer is 97.7%. So that is it.